This is the last question of the series, and while it may look scary from the student perspective, it's not, because if you read the question, it says that the circuit below is to be used in critically damped configuration, and we see our value of R is not given, L is given, capacitance is given, and the question part 1 is find the precise value of R. So in overdamped case and underdamped case, we find ranges of R, values of R. But in the case of a critically damped configuration, the component values must be some exact values for that to happen. This circuit is to bring an initial condition on this inductor. This circuit is to bring an initial condition on this capacitor. So at t is equal to 0, the switch goes from here to here. This is discarded, and at t is equal to 0, this goes from here to here, so this is discarded. So the purpose of these two parts is just to bring initial conditions here. Sometimes it's given, sometimes such a circuit is made, so it is not something difficult. The second part is discussing about the initial conditions, and we will look at that later. But right now the question is, this circuit is a series RLC circuit, is critically damped, and for critically damped circuit the condition is alpha should be equal to omega 0, and for a series circuit it is R over 2L, and this is for all circuits, types of circuits, 1 over LC, and or we can say that R must be equal to 2L over square root of LC, or 2 times L over C square root. So R should be equal to twice L, which is 200 Henry, is a large inductance, and C is a small capacitance. We are going to get 8, 40, 15, 15 over 15 square root, 2 into 15 square root over 10 raised to the power minus 3, or R should be equal to 2 times square root of 15 kilo ohm. For this exact value of the resistance, we are going to get a critically damped circuit, and this value roughly is 7.75. In fact, the value should be exact and is 7.745966692 and so on. 7.746 kilo ohm. You see, it's very difficult for a resistor to get to this value, and this making this circuit a critically damped circuit by your own interest is not possible, because from where you are going to get this exact value of components. So making a critically damped circuit is not often what is required or desired, but sometimes you are making an underdamped circuit, or you require an overdamped circuit, and you come up with a critically damped circuit by luck. So this is how things go here. So this is the first part. The second part asks for the value of IR before and after switching at t is equal to 0. So before switching, when this switch is in this position, so there is this circuit, independent circuit. When this switch is in this position, we have this circuit here. So nothing is connected here, nothing is connected. The circuit is not complete. So IR before switching is 0, and after switching, this capacitor has charged to minus 20 volt. If you look at the polarities, minus 20 volts, and this inductor has a current of 4 milliampere flowing through it, which will stay there after switching as well, and this is going to stay there after switching as well. So after switching, the circuit is, we have a source of, this is exactly at this instant t is equal to 0 plus, we have a 100 volt source. We have a capacitor that is charged to this voltage of 20 volts. I've corrected the polarity, and we have an inductor with a downward current of 4 milliampere, so I can replace it by a current source, and then I have a resistor through which the current IR flows. So you can very easily see this gives the whole thing away. IR 0 plus is 4 milliampere, because this is one path all in series. Obviously, if this current is 4 milliampere, this cannot be something else. So with this circuit, I have shown you that even if the circuit looks like a lot of components there, they may be discarded. Some parts of the circuit may be discarded because of switching, and whatever left is either a series RLC circuit directly, or can be resolved to a series RLC circuit, or a parallel RLC circuit, or can be resolved to a parallel RLC circuit in the natural response configuration or a forced response configuration. And so things shouldn't be very difficult if you can only solve and understand these 7 problems and do them all by your own, and then 2 3 other problems from the book or some other source all by yourself. You should feel very confident that you can do this very easily.